All right. Hi, everybody. Thanks for coming. Appreciate you being here. Happy Thursday. Uh, for my reminders for today, um, so lab one should be graded. As of this morning, I graded if you resubmitted it should be graded. Um, make sure that if you worked with a partner, you have to put their name in the assignment comments. So like, I didn't do this ahead of time. So let's go to like, I don't know, let's do this one. If I'm a test student, then I can just like, oh, this is really large. I can just add a comment. And then if I didn't have this one, I would be able to, there we go, send comment. So yeah, so just make sure you comment. This is the person that I worked with. Um, because that's really important for me. Because then if I go in and I see your code and I'm like, this is just like this other person's code, it like same errors and everything. And then I have to go through the whole process. I don't want to do that. You don't want me to do that. So write your partner's name in the assignment comments. If you haven't done that for lab one, go ahead and do that. Um, I would appreciate that. And yeah, so for the labs, it should be all graded. If you got a bad grade, don't panic. You can fix it. I've left comments in your, like on your lab. And so if you go through and you look at the comments, you can see this is what this is the advice that I gave you. Go through and fix that. And then you can resubmit the zip file and I'll regrade it. I would like everyone to get 100% if possible. So, yeah, you still have time to go through and do that without penalty. So that's lab one. Yeah, because I want to make sure, because lab one is important for us to be able to like get started in Java. So once lab one is done, that's like one of the big hurdles for this class. And then it's smoother sailing from there. I messed up. Ice cream was not in fact yesterday. It is in fact next Wednesday. So if you're a math, CS, or physics major and you want to go have ice cream, it's next Wednesday, 1:30 to 2:30 in the math lounge, Galileo 116. And then I wanted to just kind of comment on like why are we learning Java in this class? So there's one option. One of the options is to just learn Python your entire CS career. That is an option for like programming one and programming two. Just use Python so that you get to not like switch it up. I think it's nice to learn a different language. So when I took this class as a student at St. Mary's and I did it in C++ and it was hard. But I think it's valuable because like once you learn one language, it sets you up well to learn another language. And it's good to learn two like different styles of languages. Like Python is used really well for scripting. It can also do it. It can also do object oriented, which we're learning in this class. So it is possible to do this class in Python, but I like using Java for it because Java, um, like the object oriented is baked in Java. Like that's pretty much the core of what Java does. So it's good for learning. Here's how you can structure your code in this way. Um, yeah. And it's also like there's a lot of financial institutions have their backends in Java. And so if you go and work for them, they're not going to like throw it out today because they've got years and years and years of all this code. And if you want to work in those companies, then Java is like the language that you got to use. So, and also it's used in web backends a lot, for like SQL, SQL. If you're working with databases, Java also integrates really nicely into that. That's my answer to that question. Any comments? Cool. All right, so let's get started for today. So, all right, so Tuesday. Yeah, question.
For the test cases on lab one,
Test cases lab 1.
yeah, I had a lot of issues where it was like, the test case was expecting an integer, but I was returning a double. So I was like failing one of the tests, even though the answer was the expected answer. Is it cool if I went through the test cases and like changed it?
I guess it should have been int. Should have been int. Yeah. Yes, please. Yeah. Any other questions before we get started? Okay. So last time we looked at creating reference types. So these are a type of something other than primitive. So we made a house type, and we've got things that so this is a class house. I can also call it a type. And this class has things that we want to keep track of, which in Java we call fields. And it has things that we want this type to be able to do. So we can call like house h dot add floor. We can add a floor to this house. We can add any number of floors to this house. We can also add or get the number of stories that this house has. So these are our methods for this class. We also had a constructor, which allows us to actually create the house object. So before we actually create the house object, we just have a class, a type that we haven't actually instantiated. I think I closed that one. So yeah, so for house driver, once we get to here, now we have a house object in the variable SMC. Here we have a house object in the variable home. So that's our kind of terminology lesson. And so I'll keep using it so you can keep getting familiar. We looked at how assignments, equality works. We tested out some of the methods here. Let's see, what did we do next? We looked at strings. We talked about how we can concatenate strings with plus or plus equals. We looked at comparing. So comparison of two strings gives you the dictionary order, the lexicographic order, of does this string come before this one in the dictionary. We looked at string equals. We looked at parsing a string to like a double. And we saw getting the length, and we saw getting the substring. Then we looked at arrays. We looked at how to declare arrays, how to allocate space, or just specify these are the exact values that I want in my array. Then we looked at array lists, where to add something, we use .add. To change a value, we use .set, and then we give it an index. And then, so the 3 here, that's the index that we want to change. And then the 7 is the new value, the new element. And then we looked at the for each loop, or the enhanced for loop, to see another way of going through a collection. And so then I think we ended up with the length of strings that we didn't end up finishing. So if you did finish this, that's great. If not, we'll come up with a solution. And so for this, I would like you to tell me what to do. So here we've got our for each loop. where the for each loop does this unpacking of the collection for you. So we've got the collection on the right-hand side of the colon. That's the array list of strings. So down here, I set that up where I said a.add, and then, hello, my name is your name. So for me, that's Sarah. And then I want to print, here's how many characters are in all of these strings. And so the for each loop takes that list of strings. So that list looks something like, hello, my name is Sarah. And so that's what my array list looks like. And so when I'm in this for each loop, it takes each element and sets it as a variable s. So the very first time I'm in this loop, s is going to be hello. The next iteration, s is the string my. The next one, s is the string name, and so on. So we can test it out. If I do sys out and just print s, we can see what this behavior does. So I'm actually going to comment out this because that prints additional things. That prints like the final answer. And I just want to print, here's each string. So if I do that, and I run that, then we get, hello, my name is Sarah. So for each time we're in the for each loop, it prints, we said print s, and it does that unpacking of the list A for us. Okay, so that's kind of how that works. So now, what do I do to actually solve this problem? So I've got some variable chars that I want to return. It's an integer. I defined it up here. So how do I make chars do something correct? What do you think? Yeah.
Have like a character for chars, and then like you set it plus equals like a length.
Length of what? Of s. Okay, yeah, that's basically it. And so for Java, the s dot, to get the length of a string, you call the method. So it's s dot length parentheses. And that's pretty much it. Like, and so the alternative of doing this is if we were in like a normal for loop. So one of the things VS Code lets you do is I could just type for int I equals 0 and all that stuff manually. Or I could do the for I snippet that VS Code gives me. And so this, I mean, it gives me I equals 0, I is less than, what would we want for array dot length? What would we want to replace this with? If be a dot length, right? No, it's a dot size. For array, so for array lists, it's size. For strings, it's length. Yeah.
It's like just shortened, or not shortened, but like more condensed version of like.
Yeah, yeah. So this is what I wanted you to do for the activity, and so this is our alternative version. So we would say, let's say int chars 2 just so that we don't mess up the actual thing we want to return. So we would say chars2 plus equals what? Something dot length. How do we get each string in A? How do we get like the very first string in A? Yeah, A dot get. And so then we'll give it the index. We've got I. And so so here we've chained these dot operation. We've chained the methods. And so A dot get I, that gives us a string, right? Because our array or our list A has strings in it. So A dot get of I gives us a string. Then if we do, let's call this, we call this X. If we do X dot length, that gives us an int, right? Because a string has a length. And so if we chain A dot get I, that's a string. And then we call dot length on that, that gives us a number. So two ways to get to it, but I think the benefit of using this is it kind of helps us to know that like this is a string, and so I can call just s dot length. But either way of doing this, it's equivalent. So you could have chosen either one. It's just what you as the programmer are more comfortable with when you go to implement this. Okay, so let's actually test it out. So we've got chars. So I'm gonna comment that, count that line, and then just print, here's how many chars are in this array. And if I run that, I get 18, which sounds about right. Okay, all good? Okay. Okay, so that kind of concludes our string and array sidetracks. Now we're going to talk about input and output. And in order to do that, we need to talk about what to do when things go horribly wrong. So exceptions, we're going to use exceptions to handle sort of these abnormal occurrences. So this is something where, like, if we ask for input and then no input is provided, or the wrong kind of input is provided, then we use an exception to like throw it back to the user and say, that's not what I wanted. Please give me the thing that I do want. So exceptions are objects that store information, and that information is basically, here's what went wrong. And so it gets moved through the calling sequence until something catches it. So we'll see the catch use, and then we extract information from the exception so that we can give that information to the user. Try catch is not supposed to be used in place of if else. So if else is different than what we're about to talk about. So exceptions are really when like things have gone horribly wrong and we have to crash the program. If else is more just for like your garden variety logic. Like when this happens, do this. Or if this is the case, do that. Yeah, so try catch is for things that went really wrong. So the way it looks is we're gonna have try, the word try, and then in curly brackets, this is the risky code. That's where any risky code goes. And the risky code is basically like getting input from the user, trying to open a file, something like that. Something where we can assume that it's going to be there, but if it's like if we're trying to take a step, but the stair is not there, and then the catch is to like help us to prevent us from falling down. So we can catch as many exceptions as we need. So it looks, so after the curly bracket for try, we have the word catch, and then parentheses, we have, here's the type of exception. And then in the curly brackets, we can say, we can print some error, we can print the stack trace, to different options to say, here's what went wrong, so that the programmer can fix it. Okay, so that's the exception structure. And so if you do have multiple catch blocks, then the one that actually matches the situation, that's the one that gets selected. And then we'll see a case where we have a finally block. So not just try catch, but we can have try catch finally to, if we have to close anything or free up resources. So we'll see what that looks like. In terms of common exceptions, there's runtime exceptions, which generally shouldn't be checked, shouldn't be caught. And then there's checked exceptions. So you'll see like index out of bounds exception. If someone gives you an index out of bounds, usually that means that like we've tried to go beyond the bounds of what's possible. And so we want to not do that. So generally runtime exceptions are not caught, but checked exceptions like file not found, you can catch that. So like I ask for a file and maybe the file name is wrong, and so it throws a file not found exception. And then that means you have to go in and fix the name of the file. Yeah, so the runtime exceptions tend to be serious errors. If you call a method that, what does this mean? Call a method that may directly or indirectly throw a standard checked exception. Yeah, okay, so this bullet point is saying if, like, there are some exceptions that you really want to check, like file not found or input mismatch, that like is kind of like a no duh, like you want to catch this exception. Yeah. We can also say throw new, the kind of exception. Okay, but let's look at an example. Let me open up. Okay, so we're going to test this out with the scanner. The scanner is how we're going to get input in from the console, from the terminal, from the user. So in Python, this was just input, the word input and parentheses. It's different in Java. So we have to do a little bit more work to get that behavior. So we're going to use a scanner object. So Java has defined the scanner type, and so we're going to use that to get information. So I'll talk about this in a bit. Let's make some scanners. Okay, so I'm going to make a new class. So again, that's Command Shift P for me on Mac. On Windows, it's probably Control Shift P. And then new Java file. And then class. And I'll call this scanner test. Okay, and then I'll just make a main for me. I'll add something to that later. And I'm going to make a method, public static void, and I'm going to call this method bad scanner. So we're going to look at a couple of different examples of scanner and make it better each time. So in this first example, we're not going to use any exceptions. Don't actually do this in real life. Like follow along in the code and code along. But in like your lab or in homework or something, don't do it this way. Okay, so what we're gonna do is we're gonna say scanner in is equal to new scanner, right? The way that we are creating objects. The way that we're initializing these reference variables. And inside the parentheses, we need to say, here's where we're getting the input from. And so we're getting the input from the terminal. So that's going to be system.in. So remember, there's system.out to print to the terminal, and to get from the terminal, it's system.in. I've got red squiggly lines. And so if I go to quick fix, I just need to import it from java.util. And then that adds my import java.util.scanner above my class. So once that's good, then I just get a yellow squiggly line saying that I haven't used in yet. So let's do that. Okay, so for this one, for all of our scanners, we're going to just try to get two integers and print the maximum of them. So get X and Y, and then find the max of X and Y and return that. Or print it to the console. So we'll declare them, and then we don't want to set them equal to something because we want to get that from the scanner. So we'll say int X comma Y, and then we'll ask the user, please enter two ints. Now, this is where we're going to actually get something from the scanner. So we're going to say, and remember, this is the bad way of doing it. So if in dot has next int, then X equals in dot next int. And then, so now we've got X. So there's a difference between has next int and next int. So let's see if my tablet is working today. No, it is not. Why isn't it working? There we go. Okay, so there's a difference between has next and next. So let's say I've got like all these numbers on that I type in. When I call has next, it just looks at what's next and it says, is there something there? That's true or false. It's a Boolean. So that's why it works well for the if statement, where we can say in dot has next int. That's, is there an integer next? Yes or no. Next int is the action. That's what actually grabs that int and gives it to X. So when we say like X dot next int, then we take the 1 and we remove it from what's in the scanner, and then we give it to some variable. So it takes it away from what's in the scanner. So now 2 is the next thing in the scanner. So this is it removes it from like the up next. Okay. All right, so once we've got this, now we, let's check, sorry, it keeps So now let's check if there's another one. So we want two integers. And so we've got one. Let's check if there's another one in the pipeline. So we've got X. Now, if there's another one, say Y is equal to in dot next int. And then now that we've got X and Y, we can print the max of X and Y is, and then I could type it, but I can also just call a function math dot max and just give it X and Y. So capital M math and dot cap or lowercase max, and then just give it X and Y. Okay, so that's when things go right. So when things go right and there is a next int in both cases, then we've got our two ints, we find the max of them. Now we need the else part. So we've got if, so now otherwise, let's print to system error. So you can type that with SYSERR. That prints to the error output. So the sys out is system.out, which is just normal output. System error is the error output. And so we can print something like error, you need two ints. Like we asked for two ints, please give me two ints. So this is the else block for this bit for Y. So now let's add another. For the why is that not working? Oh, that's because I'm in the wrong brackets. So the else has to go outside the if block. Okay. And then the last thing we need to do, so for scanners and things in Java, when you open it, you have to close it. And it's probably going to give me an error here, or not an error, a warning. So it still works if I don't do it, but it's not great. So the warning says resource leak in is never closed. So to do that, we say in dot close parentheses. And then once we do that, the warning up here goes away. All right. Good for now. Okay, let's test this. So I've made a main method. Let me format this so that it looks nice. I did that by just right clicking and then do format document. That fixed the indentation over here. So let's call my method. So bad scanner. Just in the main. So as long as this method is static, then we're good. Okay, let's see what happens. Oops. Terminal. There we go. Okay, two ints. Let's do 3 and 4. And then it says max of 3 and 4 is 4. So that's good, at least. Let's try it the other way. If we give it 4 and 3, 4 and 3 is max of 4 and 3 is still 4. Let's try and break it. So if I give it 4 and no, then it says error, you need to int. If I give it no and 4, it's also going to tell me error, you need to int. Notice that so I spelled the error 2 different ways. One of them I gave it a capital letter, the other I gave it a lowercase letter. And so depending on, so in the case where I entered no second, it gives me the capital E, which it trips up at when I was trying to get Y, which makes sense. Like when we ask for the second thing, it gives us that second error message. But when I gave it no first, then it gives me this error message. So it depends how you structure your code. How are we feeling about this? Cool. This is the bad way of doing it. So the bad way of doing it is because we've got if and else to handle when something goes wrong, and we don't want that to happen. We want to have this in a safer way of handling these errors. So we're going to make now a better scanner. So I want to make a new method. It's public static, still void. We don't want to return anything. We're just testing stuff. And I'll name it better scanner. So here we're actually going to use try catch blocks. So we'll say, we're still going to have scanner in equals new scanner. And we're taking the input from system.in. So that's the same. We're also going to still ask, please enter 2 ints, because we want to prompt the user to give us something. And now we're going to have the try catch. So we spell it with the word try and then curly brackets. Inside the try, that's where the risky code goes. So for us with the scanner, the risky code is actually getting the information. So we saw with the bad scanner that if something goes wrong, then we print something to error. So if something goes wrong with getting the actual integers, that's what the sort of risky code that we want to go in the try block. So we'll say int x is equal to in.next int, and int y is equal to in.next int. And then while we're here, we can print, I'll actually just copy that line. The max of x and y is math.max. So this is my risky code. Currently, I have an error here because there's some things that I'm missing. But this is it for the try block. So for catch, so I need the word catch and then the parentheses. Inside the parentheses is the sort of exception that I'm trying to catch. So for me, in this getting 2 integers and printing the max, I think the type of exception is probably input mismatch. So that's if I asked for an int and I got a double, or I asked for an int and I got a string instead. So the type of exception I am catching is input mismatch exception. And you can see that like when I start typing, it gives me, here's all the sorts of exceptions I could try to catch. So there's a lot of options. So if you're making, like doing a project or something, and you're like, what sort of things could I catch? There's a lot of options. But for us, we want to do input mismatch exception. And since exceptions are objects, I'm gonna give it a name and just call it E. And so here I could do like E dot print stack trace. I could also print a system error. Or as required. So I can print the stack trace. I can print a system.error. And then again, we need to close the in. So we opened the scanner called in. Now we have to close it. We do that in the finally block. So once our catch block is all set up, we say finally, open brackets. We say in dot close. And so this gets executed. So if something goes wrong in try, then we've opened the scanner above the try block. So we just have to close it in the finally block. Okay. So let's, instead of running bad scanner, by the way, I commented that out just like that with command slash. So command slash just comments out a line or uncomments a line. And so I'll better scanner instead. So if I save this and then run it, let's enter two ints, 3 and 4. Max of 3 and 4 is 4. So it still works. Let's try, if I give it something, then we get some additional. So first, it prints all of this. It may show up in red in your terminal. For me, it's just normal. This is the stack trace. So the stack trace, so the stack is what holds everything that we executed. We'll talk about it a little bit more. But this is basically the report of here's where I tried to do something and something went wrong. And so to read this, you look, so at the bottom is the thing that called it first, the thing that didn't finish. And so like scanner test.main, that called scanner test.better scanner because in main we called better scanner and that failed at line 28. And then we've got next int, next, and so on. Those are all like specific to the scanner object. So that's not something that we coded. That's something that Oracle coded. So we would want to look at line 28 of scanner test to actually see what's going on. So if we go to line 28, we see that indeed, when we said for and no, then it failed at when it was trying to get the second integer. Okay, so that's the first bit. That's the stack trace. And then here's where we printed to system.error saying you didn't enter the int as required. We coded that. You could say whatever you want there. That's up to you as the programmer. And maybe it makes sense also to print it above the stack trace. That's up to you. That's a decision you can make. That's the case with a lot of things. Like some things are like, you should do this, but then a lot of things are just like, you as a programmer can make a decision. Okay, how are we feeling about the better scanner? Yes.
Is it the red line in says it can't be resolved to type.
If you hover over it and do quick fix,
Says create class.
here, let me come see.
Input mismatch exception. Delete it and try retyping it. Okay, let's do that. Yeah.
Cause that's a really common one, so it should work. Maybe add import, cause for me, it just imported automatically. Maybe if you add that at the top. Any other comments, questions, concerns so far? All right. So that's our better scanner. That works? Awesome. So one of the issues with our better scanner is that so it works if I give it something wrong in the place of those two integers, but what if I say if I have something after that, do we think it's gonna throw an error or not? Thumbs up if it's going to throw an error. Thumbs down if it's not gonna throw an error. Okay, so it's a little bit of a mix. No error. This is maybe something that we want to address. Maybe we don't want the user to put whatever they want after it. Maybe we only want for sure 2 integers. Yeah.
That works. Like the public static part, or what did you just change the integer?
No. So changing this, whoops. Changing this to int. So yeah, so like we could say int x and int y, but that's getting the data in a different way than what we want to. So right now we're looking at getting data from the terminal. And this does not affect that at all. So we need a scanner to get information from the terminal. And so what we're going to change how this try block works. Okay, so here's what I'm going to do. I'm going to copy and paste what I have in Better Scanner. Then I'm going to add stuff to it. So I'm just going to copy and paste the contents of this function. Then I'm going to say public static void. And I'm going to call this one even better scanner. And then I'm just going to paste everything. So depending on how you copied it, you may have to fix brackets to make it all happy and pretty colors. But right now it's just the same as it was before. Okay, so for this one, we want to ensure that the input is only 2 integers. So maybe we want to add some sort of documentation. So we can put comments before the function to do special Javadoc comments. We do /**. And so this ensures that our scanner only receives 2 integers and no other information. I can add comments up here where I'm saying like, this is bad, don't use this. This is why it's bad. Um, and so my better scanner uses try catch, and so that's better. When you do homework, I expect that each method has some comments saying, here's what this method does, and any like high level explanations of what we're doing. So we're going to change the try block here. So the issue here is that we just went to print the max and don't care about anything left in the scanner. So here we're going to say if, so I'll type it and then we'll talk about it. So if not, no, wait, sorry, I forgot. The other thing that I have in my notes here, another way of doing this is to have multiple scanners. So right now we just have one scanner for everything coming from system.in. Another way to do it is we've got a scanner for system.in because we need that. We need to get information from the terminal and handle it some way. One way to do it is to just get the next line and then go through that next line and then process it like that. So I'll add a comment here, goes through system.in line by line. And so we're going to, first in our try block, because it's risky getting something from system.in, we're going to say, here's my, I'm going to have a string, and I'll call it one line. And that's going to be equal to in dot next line. So we're going to get the whole next line until an enter key from the terminal. We can print like the line was, just to make sure that's what we got. This is more of like a debugging statement. We don't necessarily need that. And so now we actually have to go through it. And so scanner, we can have another scanner object that goes through our string. So we can say scanner str equals new scanner. And in the parentheses, we'll give it, here's what I want you to go through. Here's the variable, the object that I want you to scan. And that scan is that one line that we got from the terminal. And so now instead of in.nextInt, the integer is going to come from the str variable. So we've gotten the next integer from the string. And now is where we cut them off. So we say if not string.hasNext. So this says, so string.hasNext is either true or false. If it does have something left, then then that'll be true. And then remember the exclamation point is not, so that negates it. So this says if there's nothing left in the line, then we want to print the max. Else, otherwise, we print there is other data on the line. Sorry. Where did it take me? Okay. So yeah, so if there's something next, print, or if there's nothing next, then print the 2 integers. Otherwise, there's other data on the line, so we do not print the max. And then we've got the in.close. And we've got the catch block just as normal, then in.close. Any issues? Do we have any issues with our code as it stands right now? The answer is yes. What do you think the issue is? Yeah, Lachlan.
Second scan is closed.
Yeah, the second scanner isn't closed. So let's try closing it here. What's the problem? It's out of scope, right? So if we declare and define, this is line, the str scanner in the try block. Once the try block is done, we can't access it anymore. So that's why we can't close it in finally. So a way to get around this is we could say, maybe the easiest way is to just declare it outside the try block. So we can say scanner str colon or semicolon. And then instead of doing all this, we just delete the scanner part. Because we've already declared that the variable str is going to be a scanner. And that allows us to, we can add some additional things down here. So, and finally, we can say if, what was that code? I think it's if string is non-null, then close it. For some reason, I don't have this in my notes. Anyone have a? Oh. No. I think I had. Okay. So the way to get around it is to set it equal to null in the beginning. Null is just nothing. In Python, the equivalent is capital N, none. So if we set it equal to null before we get into the try block, then we can redefine it and say, this, you're a scanner, I want you to be scanning this string called one line. And then down here in the finally, we ask, is it still null? If it's not null, then we close it. If it is null, then we don't have to do anything. All right, sounds good? Okay. All right, let me add a comment there. So that you know what's happening. So we set this to null initially. So set it still initially, now it's an actual scanner in the try block. And then if something goes wrong, then close it. Okay, let's test it out. So let's do even better scanner and run it. So now, if I do 6 and 9, the maximum is 9. And it also prints the line that I gave it. So that was behavior that I did. So it prints the entire line, 6 and 9. If I did 8 and 3 and blah, 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 it says there's other data on the line and it prints, here's the entire line. So our scanner is working as expected. It takes in the entire line from the system.in and then it processes through that with our STR scanner. So in actuality, I probably don't need like to print the whole line. That's just useful for us as we're getting used to this. All right, one more kind of scanner, and then we'll be done with this one. So we're gonna have a while loop scanner. And it's gonna have the same basic structure where we're going to have a scanner, I'll call it in. And just to note that we can also set up the in scanner the same way we set up the STR scanner, is like actually try and initialize it inside the try block. So let's try that with this one. And let's say here we want to ask for as many ints as the user wants to give us. So we'll say, please enter many ints separated by a space. And let's make an array list of integers. We'll call it int. It is a new array list. So that's where I'm going to store all of the integers that the user is giving me. And I'll have my try block and I'll say, okay, so first we've got to, I'm going to set up my scanners. No, STR. So now I'm going to set up my scanners. And so we'll say in is equal to new scanner of system.in and STR new scanner. Maybe we can do this in one line. So instead of having a string one line equals in.next line, we can just take that in.next line and shove it into where we're defining the STR scanner. So it takes the next line from system.in, and now we've got our scanner ready to go to process through that one line that the user is giving us. So we don't need that anymore. So now the user is giving us possibly very many ints. So we can say, we're going to use a while loop. We could use a for loop, depending on for the length of our scanner or the length of our line. While loop also works. I think while loop maybe makes more intuitive sense for me personally. That's a decision that you can make. So we'll say while string has a next integer, because we're looking for integers. While there's an integer coming up next, we're going to say int.add str.nextInt. So while there's an integer coming up next, we're taking it and adding it to our list. Our list called ints. Okay, once that while loop is done, the user is done giving us information. Now we can actually do our work. So we can say, well, we also want to say if there's nothing else, now we can actually do our work. So we can say, let's print, and let's say the max of all these ints is a number. Now I could write a method to calculate the maximum, or I can just have a Java method do it for me. And how I get that is collections dot max. And then we have to give it the collection, which is called ints for us. So Java collections has a method called, max, and it takes as a argument the name of our collection. And so we give it ints, and then it processes through, finds the max, returns the max. All right. So that's the try block, or most of it. We also need otherwise, we can let's try throwing something. We can throw a new input mismatch exception. Okay. Now let's catch. So if we want to catch input mismatch exception, it's pretty much the same thing. E.print stack trace. We could print something, but I think that's fine for now. And then for finally, now we have the if in is not equal to null, then actually, this is actually one line, so I can just say in.close. And then we have if, what did I call the scanner? str. str is not equal to null, then str.close. So the finally is the cleaning up part of it. All right. We ready to try? No? How about now? Yeah. If you have an error for what? Yes. Yeah. Yeah. Make sure to import array list. So I also have up here. Okay. Any other questions? Okay, so now if I go to enter, oh wait, no, stop it. So now if I go to run my while loop scanner, I can enter many integers and a very big integer. And it finds correctly the maximum of all these integers is 1,000. If I run it, and I give it some other data, it throws my input mismatch exception, which is what we wanted. Okay. Any questions? Okay, so so we should have done all of this. So you import the java.util.scanner, has next something and next. And we saw all of these, which is good to go. We are going to, okay, I'm gonna try and get through the file IO, and because this is like the last bit. And if we get through this, then we can do lab 2 over the weekend. So now we've worked with getting input from the terminal. Now, if we have a file somewhere, we want to get input from that file and then use it in our program. So we're going to use the file reader type with the scanner. So let me make a new class. So Command-Shift-P, new Java file class. And my class name is going to be file IO test. And so I am going to have a main method that I'll work with. Okay, so let's do very simple where let's say I want to print the first how many lines of a file. So I'm going to have a method called read. Oops. And the parameter to this method is going to be a file name. So I'm going to give this method a file name. It's going to open a file and read it. So I can say print the first, or let's say opens file, prints the first, I don't know, 35 lines. Okay, so the structure is going to be similar. So we're still going to have a scanner. We're still going to have try catch. So we're going to say scanner, let's have my scanner named file in. We'll initially have it be null. We're in a new file, so I've got to import scanner all over again. And maybe we just print the file name just so the user knows this is what we're opening. Then let's try the try catch snippet. So if I start typing try, there's try catch and try resources. What does this do? Try catch exception E. What about this one? Okay, let's see how that worked. So first we got to set up the file in. So file in is equal to new scanner. Ah. And the source of that scanner is the file name. So we're telling it here's where where to go. Actually, no, I've missed something. We can just give it a string. But what this means is that we would go through the string of the file name. So we want to actually go through the file that the file name represents. So we're going to, instead of file name, we're going to say file reader. So we're going to use the file reader type, and the file reader knows, okay, I've got a file name. I'm going to go and I'm going to open that file. And then I'm giving the contents of that file to whatever called me. In this case, the scanner. An alternate way is file in is new scanner, and then so if we didn't want to use file reader, we could also just use file. It's an alternative type that does pretty much the same thing. I'm sure there are some differences, but for our purposes, it doesn't really matter. Okay. So we've got this scanner all set up for our input file. And now we want to, for example, just print the first 35 lines. So we need some counter to start at 0. And then we'll say while file in dot has next line. If we just left it like this, and then in the while block, and we just print file in dot next line, and then we say counts plus plus. What's that going to do?
Next row.
Say that?
Yeah, next row.
No. Because we're not working with indices here. What do you think?
Keep running until the file is fully read.
Right. So it's just going to print every single line in the file. So that could work, but we only want to print the first 35 lines, and we've got a count variable to do just that. So I'll add in some logic. So while there is a next line, and we haven't gotten to 35 lines yet, so I'll say count is less than 35. Then print the line, add 1 to counts, move on. So once we've printed 35 lines, then we're done. And then we've got the catch block, so we can say, I think the most common exception for this one is that we looked for a file and we didn't find it. So if we didn't find it, then that's the file not found exception. And so for us, we'll print the stack trace and call it a day. And then we'll have our finally block, where we have if file in is our only scanner. So we just say if file in is not null, then close it. Okay, so that's how to read the file. Now let's actually test it. Okay, so I'm gonna park it here for a second. And now we've got to actually get the file here. So if I open my Explorer, and then, so I'm currently in the source folder. I'm going to add a new folder. So there's a little folder icon with a plus here. Probably also, maybe no, I don't see it. Okay. So the folder icon with the plus in it, that's what I want. And I want my folder to be called data. So this is where all the data for this project is gonna go. And so once that's done, I've added a data folder into my project. I should have it up in here somewhere. Nope, it's not here yet. Introduction to Java, that's where I want it. File. Do I have the secret garden? I do. Okay. So I download the secret garden from Project Gutenberg. So if you go to the module Introduction to Java, you can click on it and then download it. I want to download it into my so my in-class project into the data folder. So I'm downloading the secretgarden.txt into my project where I have all of my in-class code, and I'm putting it into the data folder. So once I do that, and I go back to VS Code, I can click on the secretgarden.txt, and lo and behold, here's the novel, The Secret Garden. I'll give you a second to get all that set up. Anyone having issues getting there?
What was that, but I would say thing was like, for file reader and file not found exception, is it like, is there anything they, so I tried to like import it, with the Java default and then that, and then. put everything.
Okay, so for this one,
Oh,
yeah, yeah, so yeah,
Oh.
Yeah.
And then, what do you do after you download it?
so you download it into, or download into, or then move it somewhere. And so I have a data folder now in my project, and I want to store the secret garden there. That's where I want it to live. And then I haven't done anything else yet. All right, everyone, has anyone not downloaded the secret garden yet? Anyone still working on it? Okay. Okay, so once you do get all of that downloaded, now we just want to test it. So I'm going to, in my main method, I'm gonna call my read function. And I want to give it a file name. And the file name is data slash the secret garden.txt. If you're on Windows, it may be the case that you need slashes going the other way, and maybe two of them. If you're on Mac, it should be a one normal slash. But this should get us where we want to go. So if you're on Windows, you may need to do this. But you play around with that. And that's all we need to do, because we've got all of the functionality up in our read. And so here it's just gonna print the lines of the secret garden. So let's test it out. There we go. So first we print, here's the file name. That's just what we were given. And then it prints the secret garden. And so it doesn't print all of it. You'll notice it just prints the first however many lines we specified. Okay. Let's say that we wanted to, I don't know, add, let's say we wanted to not only just print the line, but let's say we wanted to add like a number before that. So let's say we wanted to print like the count. So maybe we could say count plus file index line. Or maybe count and then a colon. So hopefully that should print, well, if we start at 0, it's going to print 0, 1, 2, 3, so on until 34, which we could change that if we really wanted to, but I think it's fine for now. So if we run that, then we see, yeah, for sure, like that's line 27, that's line 19. And so it prints, you'll notice that even like blank lines in the document do count as a line. And so like line 1, 3, and 6 are blank, but we still print them as lines. Okay. So we've got that. All right, so I think that should be good for our code today. For active learning, let me go to that assignment. Let's have you submit the scanner test. Okay, so if you submit the scanner test, and then I want to talk briefly about lab 2. So lab 2 is now available. You can start working on it. I'll have it due, I think, next Tuesday. And so this looks at strings, which we covered on Tuesday, and file IO and scanners and stuff, which we covered today. So it's the same sort of structure. You can pick a partner, pick partners today in class and work together over the weekend. And just make sure that you comment in Canvas. You can also work on it by yourself. I recommend that you work with a partner, but that's not required. And it's going to be the same process. So you clone the repository from GitHub, and then we've got some introductory, here's what we're doing today. And then we have the activities. So there's the DNA analysis and baseball. So DNA analysis is working with strings and to count the subsequences in a DNA string. And then we've got the file processing to open files yeah. And so the process to grade it is similar. So you just run the test cases. And if you have any problems with that, then let me know. Okay, so lab 2 is assigned. Go for it. Get a partner, work together, solve problems together. And I think we're good to go. So I'll let the last few minutes just, I'll walk around and help people and solve problems. But yeah, submit the active learning, then we're good to go. Thanks for coming. I'll see you on Tuesday.